We'll probably have more people walking in the next few minutes, but I don't want to delay. We're very lucky tonight to have two speakers who are some of the prominent researchers in CFS in the country, which, you know, here in Salt Lake, I kind of find it odd that we have one of the primary clinical specialists, and now we've got three very knowledgeable researchers. It's kind of a lucky feeling that I have in that regard. Alan and Kathy Light have long research backgrounds that they've explored prior to getting into CFS research, and so we're happy that they had an open mind and a curious mind in finding this of interest. So let me introduce Dr. Light, and will both of you be speaking? You're just here for... Okay. So Dr. Kathy Light will help answer questions. And when we finish, I'll have a short announcement about a group that is going to be formed for people with CFS. So I'll say that until the end.
Thank you. Actually, it's not that much of an accident that Dr. Bateman and I and Kathy are together. It's really evolved. I think I'm going to... Can you turn this one down or off? Okay, good. Yeah, thanks. It really evolved because we have a pain research center there at the University of Utah, in which Dr. Bateman attended, and we attended, and we met each other, and we realized we had common goals in a lot of different areas. And as a result of that meeting, that's why there were the three of us here. My wife and I, Dr. Kathleen Light, and I actually never collaborated on any of our research projects until this one. So, and I won't go into exactly how that all started, but it was working out quite well. That's after 30 years of marriage, by the way, and now it's like 38 or something like 39. Yeah, right. So, yeah, okay. All right, so I'm going to tell you a little bit about something that many of you already know a little bit about. Some of you may have heard me talk here, or my wife talk here several years ago on using gene expression to come up with biomarkers for chronic fatigue syndrome. And I'm going to give you sort of the latest update of exactly where this is at, and then go off on the deep end a little bit and try to tell you a little bit about exactly what these are, because it isn't really immediately apparent from what we have. So first of all, just to introduce the cast of characters here, myself, my wife, Dr. Kathleen Light, Andrea White, who is our exercise scientist who works with us on all the protocols, Dr. Lucinda Bateman, who many of you know, Dr. Ela Singh, who's doing the XMR virus work that I will not be talking about tonight. I wish I could tell you more about that, but you can ask me questions about that later, but I'll tell you that we've been working on it for more than a year now, and we still have nothing that we really can tell you that's definitive, and I really wish I could. It turns out to be a real tough nut to crack. Okay. Last is Ron Hugan, who is our laboratory manager, who really does almost everything that you're going to see. And I may or may not mention that as I go along, but almost all the data you see, he contributed almost entirely to the development of it. Okay, so let's see if everything works here. That's working. And that's working. Okay. Yes, we couldn't have done any of this, actually, without the generous support of several of the private groups as opposed to NIH. NIH has given us some money. We hope to get more money in the future, but most of what has driven the research so far has been support and grants from OFR, the CFS Society, and the AFSA, and also from individual donors. We've been very, very fortunate to have that to put into the research that I'll show you now. Okay, so most of you know the CDC definition of chronic fatigue syndrome. I'm showing this only to remind you about one aspect of it. You know that it's this chronic or remitting, relapsing fatigue lasting 6 months or more that severely impairs function at least 50% of the time, is not relieved by rest or recovery. The only important part of that, since you all know this too well, is that fatigue is in the definition. One of the reasons I bring that up is that fatigue is one of the most poorly studied phenomena that we have, and it's very, very poorly understood. Fatigue, it means something different to every researcher that's out there, and I'm going to give you a different definition of fatigue in a minute here that most of you know very well, which is the clinical fatigue that you all experience, and many of you experience at least. It also must have 4 or more of the 8 following symptoms, and again, many of these you'll be familiar with. Impairment of memory or concentration, so we know there's some central nervous system effects. Sore throat, tender lymph nodes, so something going on perhaps with the immune system. Muscle pain, joint pain, unrefreshing sleep, muscle pain being a very prominent phenomenon. Change in type of headaches, symptoms worse at 24 hours after physical exertion. This is one of the ones that we use to our advantage to try to figure out a way to really demonstrate the biological phenomenon that's behind what chronic fatigue syndrome is. And I have that highlighted because that's what we used to actually demonstrate the biomarkers. It's often preceded by a viral infection, and something like 70% in of the population we've looked at, and several other groups have found, that 70% of chronic fatigue syndrome patients also have fibromyalgia syndrome. Fibromyalgia syndrome has a different definition, however, and that is that it's widespread muscle connective tissue pain, bilateral upper lower body for at least 3 months, hypersensitivity to pressure at tender points, at least 11 of 18 tender points and other body sites. And the symptoms generally are thought not to be worse after exercise. It's actually not true, as it turns out, but that's what the American College of Rheumatology says. Of course, both of these syndromes are pretty arbitrary. If you look at both the symptoms that I talked about for chronic fatigue syndrome, and those that are defined here, I mean, what's 11 out of 18 tender points? Why does it have to be 6 months long? You know, lots of things are just arbitrary. They just set there, and yet there's still an argument, an argument again and again, that we're not looking at a consistent population. Well, with chronic fatigue syndrome, it's really hard right now to really look at the same a very consistent, homogeneous population, because we really don't know what all the concomitants of fatigue are. We don't really understand the phenomena well enough to be able to do that. You can try to do that, and doing that, you might screen out a bunch of people, or you conclude them all and then dilute your results. So it's a real problem, which is one of the reasons we need a biomarker, something that's an objective marker that can help discriminate the different types of fatigue that people have. Okay. Okay, this is just a little graph that shows you some of our recent results, and that's going to be in the paper that I'm working on right now. This is a graph of the mental fatigue before, during, and after exercise. Now, this particular exercise task is happening here, just after baseline, mid-exercise, and then this is after the exercise is over. This is 30 minutes after the exercise is over right here. So these time points are during the exercise. It's 25 minutes of very moderate exercise. This exercise, it doesn't mean anything to you, but it's 70% of the predicted maximal heart rate. What is that? For ordinary people, that's a brisk walk down the hall for 25 minutes. Not even a brisk walk, it's a moderate walk down the hall. You don't raise a sweat, you don't really, most people, even if they're out of shape, could do this for several hours with nothing going on. This is not true for patients with chronic fatigue syndrome. Okay, so this is what happens to the controls right here for the mental fatigue. Nothing. They have virtually none to start with. The exercise doesn't do anything to it. Okay, and this is after 30 minutes after 8 hours, 24, 48 hours after this moderate exercise. These are the chronic fatigue patients up here. These are fibromyalgia patients right here. So, and as you can see, during the exercise, these patients experience an increase in the amount of mental fatigue that they report, and it continues to go up following the exercise all the way out to 48 hours. For patients who have both chronic fatigue and fibromyalgia, this group has chronic fatigue, doesn't meet the criteria for fibromyalgia, but very often they'll have many of the tender points, just not enough to make the tender point criterion for fibromyalgia. These are patients that have only fibromyalgia and do not make the criteria for chronic fatigue syndrome. And you see that during the exercise, they really don't have a problem. But after exercise, they too also show increases in the mental fatigue. This is physical fatigue. This is how tired your muscles feel. And again, all of these patients, all the fibromyalgia, chronic fatigue syndrome only, and those that have both chronic fatigue and fibromyalgia, experience worsened symptoms during the exercise and for up to 48 hours afterward. They have not come back down to the baseline here during that time. The controls, some of the controls, particularly the least fit controls, do experience a little bit of fatigue during, but you see not much compared to even the baseline up here. A little bit of fatigue during the exercise, but in fact it was right back down to baseline levels immediately after the exercise. So again, it's not a problem for controls at all. Yeah.
Is that self-identified fatigue?
This is self-identified fatigue. We ask them how much fatigue you have, and we ask them to rate it on a scale of 1 to 100. Okay? So yes. Now, and so we didn't give them the definition of fatigue. We just say, what's your fatigue? We let them come up with the definition. It's interesting. Most people know exactly what it is. Even the controls know exactly what it is, and they rate it very well, and the repeat for this is actually just as good as any pain measure. It's the pain, which is next. These are the pain measurements. So again, the controls, really no pain at all during the exercise. The chronic fatigue syndrome patients have considerably more pain to start with. Even though that's not part of their definition, is chronic fatigue, in that this particular group is supposed to not have the muscle pain because they don't meet criterion for fibromyalgia, but they still have more pain. Okay, again, so the arbitrary definition of what is fibromyalgia, what's chronic fatigue, and all these kind of things, that shows us some of the arbitrariness of these definitions. But you see that it does get worse following the exercise, and continues to get worse up to 24 hours, maybe drops off a little bit, never comes back down to baseline. For the fibromyalgia patients, it's not too surprising. They have more pain to start with because that's part of their definition, but they also continue to get worse, even though the American College of Rheumatology says they don't get worse following exercise. They do get worse. They have more pain. The chronic fatigue with fibromyalgia, they are the worst of all. They start with a lot more pain, and it gets worse and worse and worse. Okay, so this is just to give you an idea that we can actually scale this, and that it looks, this gives us a pretty good impression of what's the difference between a patient with chronic fatigue syndrome, fibromyalgia, and control patients, okay? Exactly what they're experiencing. And I think this is something you all, any of you who have chronic fatigue syndrome, you know this is what happens. Any of you who live with somebody who has chronic fatigue syndrome and don't believe that those people, this is what happens, okay? Okay, the problem is that because the major symptoms here for both of these syndromes, fatigue and muscle pain, the problem is both of these symptoms are subjective. What do I mean by subjective? It's something that only you know you really have. You can tell somebody else you have it, but there's nothing by looking at that person that definitely identifies that you have it. We don't have a blood test that measures it right now. We don't have any other way of knowing it other than the fact that they tell you. That's what it means to be subjective. So the question then is how to objectively determine chronic fatigue syndrome and fibromyalgia syndrome. How can we make this objective? It's something that if you looked on a piece of paper, came off a graph from some measure, that people would say, you've got chronic fatigue syndrome, you have fibromyalgia syndrome. And we determined early on that a possible solution was to use gene expression profiling of genes related to the symptoms of fatigue, muscle, and pain, and immune dysfunction. So we picked genes that we knew were related to the final symptom outcome. So we wanted to try to find the genes that were basically making the proteins that were detecting fatigue. We wanted to find the protein receptors that were sending a signal to the brain saying, I'm very, very tired, don't go on, don't make any more movements. We wanted to find the gene that was responsible for the signaling of muscle pain. We wanted to find genes that were related to immune dysfunction. So we concentrated on trying to find what those genes were. And I won't go into exactly how we did all that, but we did. And we used some mouse models actually initially to try to determine what those genes were. And also had some very good friends out there in the scientific community who were interested in determining what muscle pain was, and as a result of that, they really did find out what some of those molecular receptors were.